Hidden inside every Tesla vehicle is the key, the AI-4 FSD hardware. This chip's not fully understood by the majority of Wall Street analysts, and therefore they seem to miss the innovations that this company are making. However, this chip unlocks an imminent product, the Cybercab. This Cybercab is about to address a completely new market, a total addressable market into the trillions. If Tesla are able to execute on the scalability of the Cybercab and the Model Y, which they're able to produce at 5 seconds per unit for the Cybercab, 33 seconds for the Model Y, they could grow and produce enough vehicles to be able to actually impact this market and penetrate these different states across the US. The execution of this product is key. And as an enthusiast in Tesla, as a Tesla investor, you really want to know that this company are building this business model which becomes a service as a subscription model where there's a completely reoccurring income and revenue, and also the margins on this revenue are so high that it completely takes the Wall Street analysts by surprise, and they're unable to model just truly what this company is worth and could be worth. Peter Beisel, who is an ex-Rivian software engineer, his view and his understanding and explanation in his technical writing break down in the most simple way possible just why this company are so far ahead of all the other companies that use some sort of fully self-driving known as LiDAR, but it doesn't completely protect them from all of the different edge cases and all the different maps and roads and different geographical locations around the world the way that Tesla's fully self-driving does. And I think that they're prepared, they're ready for unsupervised, which means that they will not need any teleoperators, and the amount of critical interventions reduces to the point where you need to drive over 700,000 miles before you have any major accidents that would require any interventions. So if you like anything to do with understanding the technology behind these innovations, especially with Tesla, like, subscribe, drop a comment down below, and we'll get straight into it. Let's go. There are fundamentally two obstacles that stand in the way of fully self-driving and its ability to penetrate the US market. The first is regulation, and the second is the hardware, the compute required to train these models to be able to then use them in the cars to drive autonomously. Now, regulation has become much more positive, especially with the new Secretary of Transportation and the Department of Transportation being way more positive towards regulation and helping support fully self-driving across the states. The second is the hardware that Tesla have. They have 50,000 H100s, and that's all set up and ready to go and integrated. And they also have, combined with that, 20,000 of their AI-4 computers. This creates the supercluster known as Cortex, which is their data center used to be able to train and create new models for fully self-driving. So I'm going to go into the breakdown of how you have this inference data center train and use all of the information that's collected on the roads, and how that leads to the updates that go into the cars, that leads to the actual input to output where you have the car brake, steer, change lanes, and drive autonomously. The over 6 million Tesla cars on the road have cameras fitted into them. These 8 cameras are constantly reading situations. They're taking in different frames of what they're capturing on the road. They can be in 2 different states. They can be activated and driving autonomously, or they can be in shadow mode, mimicking and following what the driver's doing in order to continue to learn. There are 4 really important steps that are used to create the fully self-driving models and software. The first is the training data that's then fed to Cortex with the H100s and the Dojo 1, and this is what creates the models. The models are then used in the cars. The car has a computer that's constantly collecting more data that's sent back to the training data to create that flywheel. Then you have the inputs and the outputs that actually lead to the car driving and steering and braking and changing lanes on the road. Tesla use a neural end-to-end network, which is basically a brain. This is going to take all the training data and separate it into certain categories. So just like a brain will take the arts, the maths, the physics, the science, the music that you might be learning, the sport, any specific hobbies that you might have, and it will separate and process that information and that training separately in the brain, so you're able to categorize and select for that information when you need it. That's exactly how the Tesla fully self-driving training data works. It takes all of this information, it puts it into specific categories, it labels all of this information taken from the car specifically for pedestrians, for lane changes, for different gradients on the road, for different signposts and sounds that it hears. and it organizes all of this different information and selects for the best information, and it puts it into specific categories so that it can apply it for braking, for acceleration, for steering, for different grid types, road systems. Once it has all of this grouped information, this data, it's able to then train the model. Tesla uses camera data predominantly to train its different fully self-driving versions. This is what separates it from other companies, because it's got the cameras and the sensors on the outside that take in all of this visual frame that can be processed in the neural end-to-end network. They also have GPS data, they have vehicle state data, they have the audio data, so sirens and specific sounds that the car needs to be able to navigate and work its way around. They also have context data, the actual car's state, what's its battery capacity like, how many miles has it driven, and all of that is used and it's then separated into specific batches. Now, this is where we get even more deep, but it's so important to understand this part. All of these different inputs are categorized into batches. All of these batches are used to create the most optimal, efficient, effective output. So you can imagine there are millions of different inputs for just specifically one category. So let's just imagine we're focusing on the brake pressure required in order to make the most effective stop at a red light or behind a car. Now, the car is taking in all of these different batches of information. Say batch 1, it allows the car to brake at this specific pressure and it puts the car just behind the car in front. The second batch is a little bit more effective, but it's still not the exact result that they need. When they have this different discrepancy between the different batches, they can start to create through backpropagation, which is basically if they need an 80% hit rate for this brake pressure, but they're only at currently 65, that 15% that they need to get to their result, they can go backwards and check, okay, we need to refine the inputs to be able to get that exact result to be 80% of the brake pressure required. So once they have all of these batches for every specific scenario, from steering to driving on specific lanes, from turning at a certain angle, from braking at a certain specific light, reading specific signs, they will have every single result that they want to hit the most effective and optimal level to be safer than a human driver. And they will backpropagate the different batches and inputs to make sure they've got the most optimal result. And they'll keep doing this. And as they're doing this, this is what the neural end-to-end network is doing. The hidden layers are creating the most optimal scenario so that the car is being trained to become the best, safest, and most effective driver. Once they have that result, as close as they can to the optimal result, they will create the new version of fully self-driving. That model is then sent over the air through an update to the car. The car will now be using that model to drive. Now, the car won't be at that time able to change anything. It will only have what it's currently got in that fully self-driving version. But the car will then use that version to apply the brake pressure required, to take the right turn, to make sure they're changing the lane effectively, to slow down behind the car when they need to read all of the different signs surrounding the car. But it won't be able to do anything new. It will only be as good as the version that it's had. So that's where the car continues to collect more and more information, send it right back to the data center, Cortex, where all of that training starts again, all of those specific batches. And so you can imagine this has been happening for multiple years. This data set is growing. The real data that Tesla have is what separates them from all the other car companies, because they've been able to capture real frames from visual driving, miles of driving that's been able to then be trained for specific edge cases that no other car company has. So this is what separates them. And I know it's a very complicated explanation and trying to keep it as simple as possible, but it's through understanding that you understand that Tesla have basically created such an advantage, such a moat around this product that it's going to be hard for any other car company to compete. Hence why they would have to then communicate with Tesla in order to license their fully self-driving for their own car company. The final part of this is the FSD Convergence, which is where you have different parameters and the compute time. Now, the parameters are made up of all the different scenarios, the edge cases, the different lane changes, the brake pressure, the acceleration, and the time it requires to compute all of that. The second part is the data. How much data are we able to collect from these cars? And then again, how much time it takes to compute all of that, how much time it takes to train that data. And when you have the parameters and the data and the compute time, so you basically have all the data, you have all the parameters in order to create the inputs required to train and create a new model of the fully self-driving, and you have the compute, the H100s and the Dojo 1s in order to process all of that data, the different batches. That's when you can create an unsupervised fully self-driving model, which is pretty much what Tesla have said they have and what this cybercab's going to resemble. The main milestone to be safer than a human is to be able to drive for 700,000 miles without any critical interventions, without any human needing to be involved in the fully self-driving autonomous vehicles. Once you reach that milestone, it's exponential. This purple line shows Tesla's trajectory on the way to becoming fully autonomous without any critical interventions. They're already at the milestone of 1,000. They're already at the milestone of 10,000. And they're now working towards the 700,000 miles without needing any critical interventions. That would mean a step change above Waymo, which is the only other competitor in the USA in terms of fully self-driving ride-hailing services. How could all of this be relevant? As we enter into a completely autonomous decade, you have only so many companies in the world that are able to really compete for this total addressable market that is in the trillions. And as Tesla is the most sophisticated, the most advanced, and the furthest ahead, they could end up penetrating all of the US and have a potential monopoly over this market. And that would have such a massive impact on the company, on the price of the stock, and on the business model and how it's modeled and analyzed by Wall Street pundits. And so just understanding how far ahead and how sophisticated their software is allows you to apply it to understand that that longer term mindset with this company could potentially be very life-changing. So I hope that this breakdown of fully self-driving and Tesla's fully self-driving and Peter Beisel's technical data and everything that he's provided is helpful and gives you confidence in the direction that Tesla's company is going and the excitement of just having an autonomous future. And if you got any value from this, please like, subscribe, comment down below. I'll see you in the next one. Thank you very much.